Okay, in section 10.3, we're going to use relationships of arcs and chords in a circle. First thing we need to do is review what a chord is. A chord is a segment with endpoints on the circle. A chord will divide the circle into two arcs, the minor arc and a major arc. A diameter, remember a diameter goes to the center, will divide a circle into two semicircles. So in the same circle or in congruent circles, remember congruent circles have the same radius, two minor arcs are congruent if and only if their corresponding chords are congruent. So if arcs AB and CD are congruent, they can only be congruent if chords AB and CD are congruent. So, some examples. Find the measure of arc XY. So I look and see I do have congruent chords, and arc XY equals 105. In number 5, see that I have the central angle SQR. So arc SR equals 85. I have congruent chords, so that means that TU equals 85. And then in number 6, I can see that I have arc BC is 100. I have congruent chords AB and AC. So that means arcs AB and AC are the same. So 2x plus 100 must equal 360. 2x equals 260. So each of the arcs equals 130. If a chord is a perpendicular bisector, so if TR bisects SQ, or I should say SQ bisects TR, then that first chord, SQ, is a diameter. So if QS is a perpendicular bisector of TR, then QS is a diameter. And if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and the arcs. So if EG excuse me, is a diameter and EG is perpendicular to the chord FH, then HD is congruent to HF, and arc DG is congruent to arc FG. And the last theorem here, in the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So remember, in order to be equidistant from the center, the perpendicular distance from center must be equal. So AB congruent to CD, the two chords, if and only if EF equals EG. Okay, looking at some examples, I can see I have a diameter. It's perpendicular, so it bisects the chord. 12x plus 7 must equal 3x plus 16. Solving. In this one, I have two chords equidistant from the center, so the two chords must be equal. In number 9, I have a diameter perpendicular to a chord, so it bisects the chord. In number 10, I have two chords equidistant from the center, so the two chords are equal. So x equals 9. In the second one here on this page, we have the two chords. They're very small. They are equidistant from the center. So, or they are the same length, I'm sorry. So they would be equidistant from the center. Solving for x. So x equals 4. The next one, we have a diameter perpendicular to another diameter. So they bisect each other. 14x minus 9 equals 9x plus 21. Solve. X equals 6. In our reasoning section, what can we conclude about the diagram? So first thing is, what do we have in the diagram? We have two chords congruent, so then minor arcs congruent, arc AB congruent to arc CD. In the second one, we have two minor arcs congruent, so corresponding chords are congruent, so segment AB congruent to BC. And the last one, you have a diameter perpendicular to a chord, bisects the chord, so AD will be congruent to BD. In our last section, identifying diameters, the writing's already here, so I'm just going to give you some audio for it. In determining if we have a diameter, first off, the diameter must be perpendicular to the chord, and it must bisect the chord. So in number 13, you can see that PR bisects SQ, but it's not perpendicular, so it would not be a diameter. In 14, you have perpendicular, two chords basically perpendicular, but it's not showing that it's bisecting. And in 15, you do have perpendicular. We have the two arcs up here, QR is congruent to arc RS. So that means the corresponding chords are congruent. And so that would make those two segments inside there congruent. It would be a bisector. Because it's bisecting the arc. So it not only will it bisect the chord, it'll bisect the arc. And then the last one, we don't have perpendicular, we don't have bisecting, so it is not, neither one are diameter. And that ends the section 10.3.